adding and subtracting polynomials. So before we start messing with polynomials, let's get some vocabulary out of the way. So first of all, polynomial just simply means an expression with one or more terms. And let's remember from back in August, terms are things separated by a plus or a minus sign. So for example, 2x plus 7 is 2 terms. 2x is a term and 7 is a term. Poly simply means many, and nomial simply means number, so lots of numbers. So here are a few examples of polynomials and their mathematical names. So if you just have a single term, like a 6 or a 5x or a 2x squared, this is a monomial, meaning one term. If you have something with two terms, like 5x plus 8, for example, this is a binomial, meaning two terms. If you have something with three terms, like 3x squared minus 4x plus 2, this is a trinomial, meaning three terms. So these are the names you're going to be hearing throughout this lesson. Monomial meaning one term, binomial meaning two terms, and trinomial meaning three terms. Now, the standard form of a polynomial is we write this in descending order of exponents. So start with your highest termed exponent and then go down to your lowest. So for example, if you have something written as, if you are given 2x to the third plus 4x to the eighth minus 2x to the fifth, we rewrite this starting with my highest exponent of 4x to the eighth. Then we go to the second highest, which is a 5. So a negative, make sure you carry this symbol, negative 2x to the fifth, and then my lowest exponent would be a positive 2x to the third. So this would be the standard form of the given polynomial above. Now, when we add and subtract polynomials, we have to think of like terms. So let's review. Like terms are terms that have the same variable and the same exponent. Both things have to be the same to be considered a like term. So for example, 2x to the third and negative 5x to the third are like terms. 2x squared y and 5x squared y are also like terms. What are not like terms is something like 2x squared y and 3xy squared. These are not like terms because the variables and the exponents are not exactly the same. This has x squared and this has an x. This has y and this has y squared. So these variables and exponents are not exactly the same, so these are not considered like terms. Now, when combining like terms, we've done this before. Remember that the coefficients, the numbers in the front, are either added or subtracted, but the exponents will stay the same. The exponents remain the same. The only time exponents change are when you multiply or divide. When you're adding or subtracting, the coefficients are what are affected. So because we're simply adding and subtracting today, our coefficients are the only things that will be changed. Exponents will only change with multiplication and division. So let's look at some examples. Let's look at adding like terms. So for adding like terms, it's as simple as combining like terms. So for example 1, we have this polynomial added to a second one. That's the only reason these parentheses are here, is to tell you which polynomial is separate from the other. Now, there is really a positive 1 here in the front, but let's think for a second. If we multiply in positive 1, nothing changes. None of those numbers on the right are going to change. So we can just ignore the parentheses and we can begin adding like terms together. So I'm going to start here. Negative x to the fourth and 3x to the fourth. If I add those together, we get a 2x to the fourth. Then we have x to the third and negative 5x to the third to make negative 4x to the third. We can also add negative 2x squared and 7x squared to get a positive 5x squared. We can then add negative 6x and negative x to make a negative 7x. And we can add 5 and -9 to make -4. Now notice, none of my exponents change from the like terms. X to the fourth and x to the fourth added together still make an x to the fourth. What changes is the coefficient. Coefficients are repeated addition. So exponents do not change when you are adding or subtracting like terms. The last thing we need to make sure this is in standard form. So we have 2x to the fourth, to the third, 2, 1, and no x's at all. So this is in fact in descending order of exponents. So this is my final simplified answer to the addition of the above polynomials. Now let's look at example 2. So we are adding, because there's a plus sign in the middle, we are adding this polynomial and this one together. So again, we do not need to worry about the positive 1 in the front because distributing a positive 1 will change nothing. So we can go ahead and begin adding like terms. So 3x squared and -4x squared are like terms. So 3 plus a -4 is a -x squared. Then we have -5xy squared. So this has two variables in it. So this needs a like term. However, this is not a like term. Notice the squares on the wrong one. This is xy squared. This is x squared y. So these are two different terms. Well, I don't see a like term with -5xy squared, so I'm simply going to drop down -5xy squared. Well, my next term is y to the third. So I see y to the third plus a -y to the third, which makes 0 y to the third. Then my last term is 2x squared y, which does not have a like term. So we're just going to leave 2x squared y exactly where it's at. We can simplify this a little bit further. 0y to the third is just 0. We don't need that term. And then to get this into standard form, we first look at it alphabetically, then look at the exponents. So -x squared will be first. 2x squared y is actually second. Then we do -5xy squared. Because if you look at your x's first, 2, 2, 1, and then y's would be secondary if I had more terms. So this is the final simplified version of the addition of the original polynomials. Pause the video, try examples 3 and 4. And here are your answers for 3 and 4. If the order of this example with the double variables in the terms is a little bit different, that's okay. The ordering of things with double variables is a little bit harder than the ordering of things with single variables. So as long as you have each individual term with the correct signs, it is a correct expression. Now let's look at subtraction. So subtracting polynomials is exactly the same thing as adding polynomials. It's just you have to remember that multiplying a -1 actually changes things. So if we look at example 5, 2x to the third plus 6x squared minus x plus 1 minus the entire polynomial 8x to the third minus 3x squared minus 2x plus 9. So before, we could just ignore the parentheses and begin combining because distributing a positive 1 didn't change anything. But distributing -1 will actually change my signs. So negative times 8x to the third is -8x to the third. Negative times a -3x squared is a positive 3x squared. Negative times -2x is a positive 2x. And negative times 9 makes -9. So there is an additional first step when you are subtracting. Now that we have distributed the negative, we can simply drop down this first one because there's no negative sign out front. So we can just drop down the first one without the parentheses because, again, multiplying through by a positive 1 will do nothing. Now that we have distributed this negative, we actually are adding these polynomials together. So now we can do the same thing we did in the previous examples and combine like terms. 2x to the third plus a -8x to the third makes -6x to the third. 6x squared and a 3x squared makes 9x squared. -x and a positive 2x add together to be a positive x. And positive 1 plus -9 makes a -8. And this is in descending order of exponents, so this is the final simplified version of the subtraction of these two polynomials. Example 6 will work similarly to the example number 2. Except again, you have this -1 in the front you have to take care of first. So a negative times x squared is negative x squared. Negative times negative 9xy is a positive 9xy. Negative times negative y to the third is positive y to the third. Negative times 3y squared is negative 3y squared. And again, there is no negative sign out front on the first one, so we can simply drop this first polynomial down, and we are adding these together. So we have 7x squared and then plus a negative x squared makes 6x squared. Negative 8xy and 9xy are like terms, and that ends up being a positive 1xy. Negative 2y squared and negative 3y squared make negative 5y squared. We have negative 9, and there is no like term with negative 9, so we're just going to drop down negative 9. And then we have y to the third, which again, there is no like term with y to the third, so we will drop that down as well. Now that we have combined everything, let's make sure the order is correct. So 6x squared plus xy plus y to the third first, then minus 5y squared, then minus 9. Pause the video, try to do the subtraction for example 7 and 8. And here you should have had, for example, 7 and 8. So 9 and 10 are some examples that mix together addition and subtraction all in one problem. And so we're going to basically, if there's a negative in the front, distribute out a negative. If there's a positive, distribute out a positive 1. We're going to mix together addition and subtraction. So we have one polynomial subtracted by another added to a third. So the negative here will be distributed to this very middle polynomial, and that's it. That's why these parentheses exist. So this negative will change this to a positive x squared plus a positive 5x to the third changes to a negative 5x to the third, and negative times a negative 5 is a positive 5. On the other two, distributing out positive 1 will do nothing to them, so we can just drop those down with addition signs. 7x to the third minus 9, negative 9x squared minus 8 plus the middle one. Now that we have successfully distributed out any negative sign, we can combine like terms as usual. So negative 9x squared and x squared make negative 8x squared. Negative 8, 5, and negative 9 are all like terms. I have 3 this time. So let's see. Negative 8 and negative 9 combine to make negative 17. Negative 17 plus 5 makes negative 12. Then we have negative 5x to the third and 7x to the third to make a positive 2x to the third. Last but not least, make sure you're writing it in standard form. So 2x to the third minus 8x squared minus 12. Pause the video, try example 10. And here's your solution for example 10. Let's look at some applications. So with addition and subtraction, really the only application that is available to us is perimeter. So perimeter is the only real application that we have because that is the only thing that adds all the sides of a shape. So perimeter is adding all sides of the shape. Add all sides. So for example 11, you would simply add all of these like terms together to find the perimeter. Now you can rewrite this kind of like the ones above where they're all side to side, or you can do this straight from the figure. I have 2x squared and a negative x squared. Those are the only x squareds I have, so I can add those up and make an x squared. I have 4x and 4x and 8x, all of like terms. So 4 plus 4 makes 8, and 8 plus 8 makes 16x. Then we have 2y and negative 3y to make a negative 1y. And then 2y squared is left without a like term. And so if I reorder these to be in the correct order, we have x squared plus 16x plus 2y squared minus y. Now, for rectangles, we have to be a little bit careful. So for example 12, find the perimeter of the rectangle below. There's a couple ways you can do this. Remember that perimeter is adding all of the sides together. So we have to remember that this is also 3x plus 2x squared minus 7, and this side is also 9x squared minus 5. There are 4 sides to a rectangle. So if you simply add this side and this side together, you're missing half of your rectangle. Now that I have labeled everything, you can follow the same way that we did back on example 11. Find all of your like terms and add them together throughout all four sides. But there is a shortcut to this. We know that this is exactly the same side as this one. So what we can do is we can say that there are 2 times 9x squared minus 5 because there's 2 of those sides. And we're going to add together, there are also 2 of the other side. So 2 times 3x plus 2x squared minus 7. So if you know that some sides are exactly the same length as another, so this side and this side are the same length and there are 2 of them, we can multiply by 2. If there were 3 sides that are all the same length, you can multiply by 3. And now we can, again, simplify this. We can distribute out 2. So this becomes 18x squared minus 10. This distribute out of 2 becomes 6x plus 4x squared. Distribute out of 2 minus 14. And now we can combine like terms here. So 18x squared and 14 is 21. 22x squared. 6x does not have a like term. And then negative 10 and negative 14 can combine to be negative 24. Either method will work. Either do it with the multiplication of 2 times each side, or simply add all the sides together individually, and you should still come up with 22x squared plus 6x minus 24. Now let's look at 13 and 14. So 13 and 14 are working a little bit different. So 13 says, find the perimeter of the triangle below. Oh, sorry. Number 13 says, if the perimeter of the triangle below is 5x plus 2y, what is the length of the missing side in terms of x and y? Before we begin this problem, I want to talk about this, in terms of x and y. All that is saying is that your answer will have x's and y's in it. You're not going to have an answer of like 5 or 10. You will have x's and y's in your answer. That's all that means. So if we're looking at example 13, it gives me a couple things. First of all, it says the perimeter of the triangle below is 5x plus 2y. And it's asking me for what is the length of the missing side. So I'm trying to find out this. So use your problem solving skills. The perimeter is the addition of all 3 sides. This plus this plus this. Well, I have 2 sides. So the first thing I want to do is find the perimeter of the sides I do have. Find the addition of the given sides. What do you have? Well, 2x plus x is 3x, and negative 3y plus 2y is negative y. So that's the addition of the sides that I do have. Then, to find the missing side, that's step 2. Find a missing side. And we do that by, let's think. If this is the perimeter, and I know that this plus this missing side has to give me the perimeter of 5x plus 2y, well, that means if I take 5x plus 2y, subtract out what I already have, will give me the third side that I'm missing. So basically, the missing side will equal the perimeter minus the given sides. Now notice I put given sides in parentheses because we have to subtract all of this. So you need to make sure when you do this subtraction, you have this given sides in parentheses so that we remember to distribute out the negative sign in the front. So let's see. So the missing side, I'm going to put question mark, is equal to the perimeter, which they gave me as 5x plus 2y, minus, and then my given sides that I found earlier in step 1 is 3x minus y. So we need to simplify this to find out the value of that missing side. So distribute out the negative. So this is negative 3x. Negative times a negative is a positive y. And then we simplify. So question mark is equal to 5x minus 3x is 2x. 2y plus a y is 3y. So this is the value of my missing side in terms of x and y. So the missing side is 2x plus 3y. Pause the video and try example 14 on your own. And here's what you should have had for example number 14.